Welcome to the 9.1 Notes video part 2. We only have a few examples to do on this one, so let's get started. We are changing to solving quadratic equations and not just simplifying expressions. So my goal is to get x alone. There's multiple different ways that you can solve. You've been doing a lot of factoring this year, but we're going to come across the quadratic formula, and we're going to come across square roots here, and also just focusing on the GCF. The only type of method that we're not going to be focusing on in this video is completing the square. I might bring it up again in class, and I know you'll see it in pre-calc next year also. So if I look at number 13, my goal to get x squared alone would be taking the square root of both sides is probably the fastest way. And so these are inverse operations, so they cross out. So you'd have x equals the square root of 40. Now, please remember that you should have plus or minus here, because, as I've said in class, there are really two answers, both positive and negative, that you could plug back into this equation that can work, because either a positive or negative squared is still a positive number. So this should be x equals plus or minus the square root of 40. If we kept exact, just like earlier in the first part of the video, we could split this into 4 times 10, perfect square and not, because that does multiply to be 5 and 2, but neither are perfect squares. So my answer would be plus or minus 2 root 10, if I left it exact. Yes, these do have decimal answers, but I'm not worried about that right now. Number 14, if I am squaring a square root, these inverses cross out, so I'm just left with 5, plus squaring a square root, cross out, I'm just left with 11 equals x squared. So I have 16 equals x squared. Take the square root of both sides. This time, 16 is a perfect square. So x is going to equal plus or minus 4. Now, something good to be pointing out here is if I gave you the square root of 5 squared plus 4 squared, we cannot cross out the squared in the square root and this squared in the square root because of this plus in the middle. Order of operations tells me that I have to simplify under the square root before I perform the operation on the outside. So legally, I would have to make this 25 plus 16, which would then make it the square root of 41. So if you ever see a plus inside a square root, we cannot cancel out like this. So I thought that might be useful, again, for this class and future classes. Skipped a couple examples. Sorry about that. Let me go down to these. So number 15, we cannot do square roots because I cannot combine x squared and x's like terms. The only time you want to do square roots is when x squared is isolated. Are there two numbers that multiply to be 14 and combine to be negative 8? No, so this is not factorable. So it looks like I'm forced to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And yes, I am singing the song in my head right now. I'm sure a lot of you are too. So remember that a is really 1, b is negative 8, and c is a positive 14. In order to use the quadratic formula, it needs to be equal to 0. So we'd have x equals negative, the b is negative 8, plus or minus the square root of negative 8 squared minus 4 times 1 times 14, all over 2 times 1. So if I continue, we would get x equals negative times negative changes to a positive. So x equals 8 plus or minus the square root, negative 8 squared. Now make sure in here you're following the order of operations again. First thing, PEMDAS, we want to do is parentheses and exponents. So negative 8 squared is 64. But I would like you to also note that we have a subtraction and then multiplication. So we don't want to do the subtraction until later, but 4 times 1 times 14 is going to give me 56. And then it's still all over 2. Order of operations still stands. We want to simplify underneath our square root and get rid of it if possible. So x equals 8 plus or minus the square root of 64 minus 56, and that would be 8 over 2. And my goal is to keep simplifying this as much as I possibly can. Now, we cannot take a 2 out of these three numbers yet, because this 8's underneath the square root. It is not considered a like term with the rest of them. But what I can do is split root 8 into a perfect square and a knot. So I could get 8 plus or minus, make this into root 4 times root 2, all over 2. Let me keep extending the page here. So that would be x equals 8 plus or minus square root of 4 is 2 root 2 all over 2. And now I like to call this the triangle of numbers. Now that we have three numbers that are all just integers, we can take out a common term. So because they're all divisible by 2, my final answer exact could be, so everything by 2, 4 plus or minus 1 root 2. No, this is not divided by 2 because it's not a like term with these three, all over 1. Now, some of you might be asking yourself, do I need to write either of these ones? No, you don't. So a more simplified answer would just be 4 plus or minus root 2. So this one, the quadratic formula, was the best method because it was not factorable and we could not use square roots. Number 16 is unique because it looks like initially that it's going to be another quadratic formula question. But the reason this was quadratic formula is because none of these terms could be combined. However, number 16, I notice I have an x squared and I have two terms with an x. So instead of the quadratic formula, what we could do is we could add the 11x over here to still get it equal to 0 and have x squared plus 16x equals 0. Now, there's nothing wrong. You could do the quadratic formula. You could say this is x squared plus 16x plus 0 equals 0. And you could say that a is 1, b is 16, and c is 0. There's nothing wrong with that. But I would suggest a faster way to do the problem would be that when in doubt, take it out. Greatest common factor. If you look at these two terms, the GCF is an x. So if you took an x out, you'd be left with x plus 16 equals 0. And then if you use the zero product property and say that this x equals 0 for one equation and x plus 16 equals 0 for the other, you more quickly get two final answers of x equals 0 and x equals negative 16. Yes, you would get 0 and negative 16 with the quadratic formula also, but that is so much more work than you need to do. So this last example is for you if you'd like to try one on your own. And so just to kind of talk about a few things, yes, the directions say use the quadratic formula, but if we wanted to go through the motions anyway and first get this equation equal to 0, if I add the 3x over, it becomes positive. If I subtract the 4 over, it becomes negative. And so if I look at this quadratic, I first ask if I can use square roots. And no, I can't, because none of these terms can be combined, and we only use square roots when x squared is alone. Second thing I look for is, can this factor? And some of you might remember the split the middle term, where you would do a times c and get negative 8, and you would list the pairs of numbers that could multiply to be 8 and combine to be 3. Because there's no pairs that works for, this is not factorable, which is why you have to rely on the quadratic formula. And so if you'd like to try this problem with the quadratic formula on your own, feel free to pause the video now. All right, guys, so to check in with you, my final answer was negative 3 plus or minus the square root of 41 all over 4. And that is because after I set it equal to 0, I plugged everything into the quadratic formula. My b became negative because my 3 was plugged in here. It's mainly in here that I want to focus on. Please note that 3 was squared first and that I am subtracting a negative number, which is why this did end up becoming a plus. I would say that this is the most common mistake I've seen in the quadratic formula. So We change this to a plus because we're subtracting a negative. 4 times 2 is 8, times 4 is 32. 9 plus 32 gets me the sum of 41. And the reason I left my answer like this is because the square root of 41 cannot be split into anything that's perfect square times a naught, because no perfect squares multiply into 41. And I can't reduce these three numbers for two reasons. One, there's no GCF, and two, because root 41 is not a like term with these two. All right, guys, thanks for watching these videos. I hope this was some good review for you to prepare for Chapter 9. Thank you.